Hello everyone, my name is Chen King from Stream Processing Platform at Pinterest. It's an honor to present on behalf of team at Pinterest and share our journey of growing stream processing footprint. Pinterest is a visual discovery engine where users can find, or pinners can find their ideas like recipes, homes, or style inspirations. With billions of pins on Pinterest, users can always find the ideas that spark the inspiration. When the pinners discover pins, they can save them on their pin board and bring along wherever they go. Thanks to 470 million monthly active users on the platform, tackling and making best of it usage of data on the platform became a crucial part of Pinterest engineering. Thanks to the nature content we are serving, the machine learning, especially deep learning, became an essential part in many parts of Pinterest engineering tech stack. When we talk about stream processing at Pinterest, this is basically categorized as online data systems. Users or pinners can log on our website or use a mobile phone to browse our app. Whenever those information were logged, either from web application or from API, the Kafka web daemon will carry this log to the Kafka queue, where those logs will be processed with stream processing application built on top of Apache Flink. There are multiple data sources and destinations the application need to interact with. Notably, majority of use cases need to inference a machine learning inference. Also, vast majority of services need to deal with indexing and serving system, such as Memcached, MySQL, Kiwi Store, which are our Kiwi systems, HBase, Zen, which is our graph database, Manus, Druid, or Statboard. We also notice significant amount of use cases need to do root processing and backfill. So we actually hook up with the Mercer system that can tell raw Kafka logs from back to history. That provides a great utility for our use case, for our customers to reprocess and make sure their data is correct. Another point we want to make is actually many applications need to deal with batch system warehouse tables. So this is an intriguing situation where the batch processing and streaming processing actually make it way together. Moving up, we'll focus on all the applications building on top of stream processing platform. For the sake of time, I may not have the time to cover all of them, so just pick a few of them from each product category, and hope to walk through with you and share the things we learn and build together. The first use case I would like to share is PingStats analytic use case. The problem we're trying to solve is providing near real-time performance monitoring and content to content creators. On right side of the panel, you can see views, close-ups, clicks, as well as breakdown by each pin. Thanks to the heavy competition in online space, users actually expect the real-time data being available. In Pinterest, we have to operate with very small teams and great infrastructure cost efficiency. With that said, how we made this work with 2 engineering teams. So here is a PingStat use case diagram. Before we dive into a speed layer, Let's first walk through the historical batch layer. So basically, the data were cleaned up and written to Hive tables every hour when downstream ETL job pick up and compute stats. Results were batched right to OLAP serving system. One of the challenges with this ETL approach is the views table is getting larger and larger, so it often occur delays. So instead of adding more compute resource to the batch layer, we actually build the speed layer offering and cut down the latency from hours to seconds. Instead of clean up ETL jobs, cleanup and deduplication is done with the stateful stream processing computation inside Apache Flink. Due to a requirement from product side, we have to buffer 24 hours and later 7 days of fresh pings created in order to and get real-time stats within a couple of seconds delay. Those two things together easily make up this stream processing application became one of the largest we knew in 2020 in the Valley. In addition, part of the challenge also come from part of data source are not come from Kafka, but instead from batch processing stack. Whenever a spam user account were computed, it were broadcast to the stream processing application, where all the operator subtasks need to take the spam user account and refresh their filter stage. With that said, there are a lot of challenges to support this application. Together with the client team, we meet the challenge and get this delivered on time. Right after the product launch, we were able to see the user love this feature. There are rampant or very, very much active user usage to this feature, and more content uploads and iteration are happening after this feature launch. 18 months after application launch, the requirements and the features is just getting more and more. And the application has been able to evolve with itself, still with 2 engineers. This is the ping stat use case I would share. Next slide, I would like to cover some of the content and the content creator side of our business. Around the content use cases, there are several use cases around. For the folks don't know what story ping is, story ping is a rich form of pings compared to single image ping. Creator can record multiple videos, add images, leads, and custom tags in story ping. Right side is an example story ping user uploaded. The content is created as a secret beach at Lake Tahoe, perfect for kids. And right after this story ping gets uploaded to the platform, content understanding want to evaluate the quality, intention, interest, annotation, embedding, and performance aspect of the content. There are many, many use cases in this area. There's two focusing in the stream processing side or safety, where content quality will be evaluated in near real time. Distribution, where the high quality content can get distributed very fast with near real time machine learning. So let's use a story pin as an example. Bear in mind, this is a simplified version, and there are so many applications in this area. So here is a story pin distribution application. As you can see, there are more than one application running in this architecture. From left, you will see the fresh pins get into the channel in the platform where the content signal generation applications extract each aspect of signals and write to the content signal datasets. Meanwhile, the user signal generation applications extract the user information and write to the user signal database. The creator signal generation extract the performance and historic data of this creator and write a creator database. On top of all this, we have content review tasks get distributed with task distribution application for the human to review. Whenever the reviewer giving content quality signals, we also take this as one aspect of evaluation. All these signals are synchronized with story pin distribution application, where they look up the pin database, look up the content creator database, look at the content signal database, as well as the user signal database. When they do machine learning inference and figure out what the appropriate distribution cap should be put on. Whenever we see a low quality content, we put throttle to the distribution as much as possible. Whenever we see a high quality content, we remove the throttle in distribution cap and fastly distribute on story pin distribution indexing systems. In this way, we could make sure the low quality content get less distribution and even no distribution, while high quality content can get distributed as quickly as possible to the pinners. So they have a fresh experience of using Pinterest. Looking at these use cases, one of the challenges were the application were implemented by machine learning engineers who were primarily written batch jobs before. In order for engineers to effectively complete their job in parallel with the data flow programming model, certain abstraction is required. Another challenge with this cohort of use cases is they were implemented as a kappa architecture. So the backfill and the reprocess has been one of the fundamental asks for these use cases to function. You can often see a S3 watcher staying inside of those applications so that any backfill, any reprocess can be done right in the main app. Thanks to the dedicated work from content teams, this cluster of applications together achieve a great outcome for story pin initiative. I see much higher quality of pins created over the usage of service. Content safety policy violation were detected much efficiently thanks to human task capping along with near real-time machine learning feedback loop building in on top of Apache Flink. Follow up, I would like to cover the shopping and advertiser related use cases. So the most common question Pinterest or users or pinners have been asked us were, how can I buy the item I save on my pinboard? In 2020, the company has seriously invested in answering the user's ask. From the right side, you can see pinners could find their shopboard items available right in near their pinboard. The problem is, how can Pinterest build and maintain a shopping catalog efficiently and up to date? From advertiser side, measuring ad conversion attribution has been a challenge to all industry peers due to the segmented nature of datasets. Advertiser would only have the right campaign decision when the coverage is high enough. When it comes to the campaign budgeting and reporting system, unification of two systems has been a hope for many years in Pinterest. With help of Apache Flink, we are able to make this happen. In next page, I will use the shopping catalog use case to demonstrate how we get this done. Here is the shopping catalog use case. So shopping item candidates often comes with visual content, text, and some catalog information. In Pinterest, handle multimedia content is one of our unique strengths. You can refer to KDD 2020 paper, Shop the Look, to get some insights of how we get this done. Whenever those candidates land in our system, we do ML inference, extract the visual embedding signatures, as well as putting those content into cover IQ. Where we have a main app trying to consolidate and indexing this content into item database. This application is responsible to update its database with the latest incredible metadata information in terms of each item in Pinterest shopping catalog. It also finds the right hierarchy and index system to work. Item indexing is very important, as shown on the right image. One item from one retailer could trigger updates to the entire product chain. This app aims to consolidate segment items like yellow or blue dresses, which is actually the same shopping item. After categorization, shopping serving database will index and serve to the shopper on Pinterest. The challenge of supporting those large use cases like shopping or ads is come from severalfold. Number one, those are business critical applications of large scale. So they require really high availability. While seeing the hotspot in the cluster and mitigate all those issues became a prerequisite to onboard those use cases. Because of criticality of those use cases, we have to develop application management automation instead of paging on call whenever anything happens. Thanks to the dedicated work from the shopping catalog teams, shoppers and Pinterest could see trustworthy shopping catalogs. From the time the item was surfaced to Pinterest, we could update the catalog and surf out within 5 seconds, instead of 24 hours before the new systems. From our advertiser side, our measurement application could run near real-time conversion prediction, which significantly improved attribution conversion coverage. As spending data became more accurate compared with previous running on other stream processing framework. This new application allows us to filter invalid actions in near real time and offer our data to be audited and certified by third party. The last set of use cases I would like to share with audience are infrastructure engineering related use case applications. I picked 3 applications from this group. Those are real-time A/B testing, which help Pinterest engineer run real-time experimentation, user uptime, where Pinterest could inspect each user experience with platform at each session level in near real time. Last but not least, our matrix data aggregation handled the high cardinality of pre-aggregation data stream before writing to our time series database. So one of the common pattern of supporting infra engineering use cases is that those applications often tried other solutions and learned their lesson before approaching us. Due to scale of Pinterest, those jobs often need to fine-tune at a low level. Last but not least, any issue with those applications will impact engineering teams directly. So it's crucial to have a reliable production experience. Thanks to the dedicated work of infrastructure engineering teams and building on top of us, real-time A/B testing has been widely adopted since it was launched 2 years ago. Site reliability engineers teams will be able to tackle and respond platform health from single user cardinality within a minute. Last but not least, matrix aggregation application previously running on other string frameworks no longer suffer matrix delay, which causing flood of pages to the whole engineering teams. In the end of my presentation, I would like to take the opportunity and share some of the learning in adopting Apache Flink in Pinterest. Like many peer companies, our way to near real-time seemed more like a marathon and building the missing pieces instead of a sprint. One good example would be our data cleanup and accuracy effort right now undertaking evolve as a real-time data warehousing effort. Engineers with batch processing stack background often need to get familiar with new programming diagram in order to operate efficiently, so as stream processing platform engineers. We do see a lot of use cases just approaching us and keep challenging us to operate efficiently and scalably. The second takeaway is always focus on unique values stream processing platform could bring. In reality, application can be built in multiple ways. Understand the unique value platform could provide that alternatively cannot is important to long-term success of projects building on top of it. Finally, I would like to quote a saying from Africa. Alone, a youth runs fast, with an elder slow, but together they go far. Working with other teams and to be able to leverage each other is crucial and beneficial in the long run. Having discussion with the community and working with the industry peers is crucial to build a better future for stream processing. For more details how we write application and debug application at scale, please join our 2 session from my colleagues in my team. Thank you.